Welcome to the Blue Security Podcast, a weekly podcast for information security defenders, where we bring you discussions on best practices, tools, and implementation for enterprise security. Now, here are your hosts for today's show, Andy Jha and Adam Brewer.
Welcome to this week's episode of the Blue Security Podcast. I'm Andy, your host.
I'm Adam, your co-host.
Getting ready for some vacation, so we're recording on some off days this week. So we might be a little bit off sync on some of the news things that are coming up, but we have some good and fresh episodes prepared for you guys for the upcoming weeks. This week, we're going to talk about the OWASP Top 10 and application security. Now, neither Adam or I are experts on application security, but we know the basics, and the OWASP Top 10 is a really good roadmap, especially for defenders to have a good idea on what the most common web application software development vulnerabilities are that are trending. And one of the things that you might not realize if you haven't gone and looked at it for a while, if you're just a security analyst or security architect and you're not doing software development, is that the OWASP Top 10 actually changes over time. In fact, the last time it changed was in 2021. As well as with all of this AI and large language model discussion that has been happening, OWASP has come out with a draft for their top 10 in regards to large language models. So we're just going to talk through some of this today and get an idea, because as defenders, it's always a good idea to have an idea of these. So OWASP Top 10, it's a document that is developed for developers and web application security, and it represents a broad consensus across most of the security risks. Traditionally, these have been vetted, but now OWASP has been doing a little bit of a different methodology when they're coming up with their top 10. Traditionally, they have looked at ways to test each one of these vulnerabilities and make sure that they are, and then looking at different breaches and things that have happened over time. But with this current top 10, they actually took some time to do a community survey to ask application security and development experts on the front lines to see what they think weaknesses are that the data may not show yet. And they did that for a few reasons. Mainly because when new vulnerabilities are out, it takes time to integrate tests into tools and processes to make sure. And in order to test it at scale, sometimes a lot of time has passed and maybe that is not a vulnerability anymore, or maybe something new has come up. As we know, in security, things flow very, very fast. And so I like how they've done it, where they've taken a survey and just said, hey, this is what the frontline people think is a vulnerability, so we're going to keep this one in the top 10. Now, it's not all of them. The majority of the top 10 is data driven, but I think in this current top 10, 8 out of the 10 are data driven and 2 are based on surveys. So let's just go through the top 10. We're not going to dive too deep, because each one of these, if we go to the website, if you click on the vulnerability, it will give you an overview of that one, a description, some common ways that they have found it to be implemented, and then, very importantly, ways to prevent it. So if you're working with application security folks, or if you're working with developers, if you're in a fledgling application security program, it has some good mitigation to talk about and help your developers if they're not familiar with OWASP, because not every developer is in the business of making secure applications. Just like network engineers generally try to keep the network available, but they're not always looking at security. Same thing with application developers. They're usually looking to make sure that the application works, but not always works securely. So understanding a little bit about how to prevent each one of these when you go to the site, it'll kind of go through each one of these. So the first one on the list, the top one, is broken access control. And that used to be in the 5th position and has moved up from 2017 to 2021 now into the top position. And essentially it is the ways of access being granted insecurely, elevation of privileges, metadata manipulation, forced browsing to authenticated pages as an unauthenticated user. So these are very common. As we know, it's an identity-based vulnerability. So this is the number 1 on the list. Number 2 also shifted up from previously, is now named cryptographic failures. And that is things like if you're using old cryptographic algorithms or default crypto keys that were weak, or if your server certificate chain wasn't properly validated, that one is now number 2. Injection moved up from moved down to the 3rd position. And it says 94% of the applications tested for some form of injection, with a max incident rate of 19%, average incident rate of 3.37%. So there were 270,000 occurrences of this one, and cross-site scripting is now part of this category. Very old and very common vulnerability is now number 3.
Makes sense that injection has slid down over time. I feel like of the whole OWASP top 10, injection is one of the most well-known risks. And I think the tools to solve that have become more available in terms of input sanitizing and stuff like that. So it makes sense that has slid down. And really that broken access control and cryptographic failures have slid up. In that aligns with broader kind of security conversations where, I apologize for the tired phrase, but identity is the new control plane. Identity is still your first barrier of defense against security issues. And so having your identity buttoned up, your access control buttoned up for your web applications is just as important.
Interesting for number 4 here, insecure design is a new category that they added in. And this is where you're talking about secure development cycle and shifting left. If you want to listen to a really good episode that we had, we talked with Tanya Janka, who is an author for the book on application security. Bob and Alice Learn Application Security. And that book is actually really, really good. Teaches you how to build an application security program and talks about secure development cycles where you are shifting that conversation left. We talked about how if you were to build a house and you designed a house and you started building it, but then all of a sudden you decided to add a bathroom somewhere. It is much harder to add a bathroom after you've already started building the house than if you were to design it in. And so that's the concept of shifting left, is where you're kind of talking about security, designing security into the application rather than an afterthought.
And taking the analogy one step further, if you have a poor foundation, it doesn't matter how well the rest of it is built, that's problematic. And that's also talked about here by OWASP, that essentially when you have insecure design, it can't really be fixed easily by slap some security in front of it. Ultimately it's flawed as a concept. And so we have to redesign it to fix it, not just, bolt on some security. And so that's deeply problematic.
Number 5 is security misconfigurations, which has moved up since the previous edition. This also is a very common one. You're talking about if there's missing security hardening on any of the application stacks, or unnecessary features are enabled or installed, default accounts, passwords are still enabled, security settings on the application servers are not set to the right settings. So this is, again, something that I think is becoming more common as we're shifting left. So understanding how things are built and configured is going to be very important. The sixth one here is vulnerable and outdated components. That one has also, I think, moved up from the previous one from number 9 to number 6 now. And this was number 2 in the top 10 community survey, but it also had enough data to make the top 10 just via data analysis. So both the experts in the front line think that this is an issue, as well as there was enough data to show that this is an issue. And this is where you're looking at different components. If you're not scanning for vulnerabilities, underlying platforms, libraries, if the software developers are not testing for compatibility when things are getting upgraded. So I think the log4j would fall under this particular vulnerability, and we know how much that caused an issue. So a very big one in today's world.
I find it interesting whenever you have a gap between the community survey and the data-driven analysis. So this was number 2 in the community survey, which means when you asked people, what do you think are the top risks? What's top of mind for you? They cited this very frequently. However, the data shows that maybe it's not as much of a risk as people think it is, which is not to say you shouldn't concern yourself with it. You absolutely should. And you should take steps to better understand your application supply chain and where all those little components come from and who maintains them. Is it some volunteer maintainer in Omaha, Nebraska that keeps the whole thing running? Those are good things to know and to concern yourself with, and to have a plan to remediate quickly. However, again, there might be a gap between perception and reality. So I find that interesting here, which is not to say, again, don't concern yourself, but, just interesting to point out.
Yeah, absolutely. Number 7 is identification and authentication failures, which was recently called broken authentication, which is different than the number 1, which is broken access control. So in this one, it's more relating to identification failures. So some of the things that they're talking about here are if you're actually using weak credentials like password1 or admin, or if you allow brute force and you're not timing out the password fields. Some applications allow you to sign in a few times and then they're like, oh, you need to take a 5-minute break, right? And so building those things in, automated attacks like credential stuffing, or using plain text unencrypted password stores. So those are the ones that are in this category. I think because security has become a bit more important, under why this slid down from 2nd to now 7th makes sense to me. We have been talking about passwords and plain text credentials and stuff like that for a very long time, that I think any developer today, if they were to use plain text password stores, or not code in ways to prevent credential stuffing or brute force, that would be a known thing that they're consciously doing. And before, maybe 6-7 years ago, they wouldn't have even given it a second thought.
Well, it says in the notes here as well that the increased availability of standardized frameworks seems to be helping. So I thought that was a really good point, and I kind of honed in on that. In general, you shouldn't be building your own identity platform, or not platform, but even your own identity component of your application today. There are really good standardized frameworks for this. Most of them are low or no cost availability. And so it just makes more sense to sign in with Apple, or sign in with your Microsoft account, or one of those providers, as opposed to rolling your own. You don't need to do that. A lot of people have already done that work. When you look at I don't even know what the numbers are up to today, but at one point, Microsoft was handling literally trillions of logins per day, or per month, maybe. I forget. Anyhow, it's a huge number, right? That just gives, and again, we both work for Microsoft, the ability to find those needles in the haystack of those risks with authentication, where you can see even a very slow drip password spray attack when you have visibility across so many different accounts. And those are things you as an app developer just don't have access to, just don't have signal to see. And why would you want to spend your time worrying about that when there's professionals who will do it for you? So I thought that point, Andy, I think your highlight was good too, that there's more awareness of security. There's more awareness of how important identity is to security. But ultimately, there's way more providers than there were in 2017 that will essentially handle all of the identity stuff for you so you don't have to. So that's another point too.
Number 8 here is software and data integrity failures, and it's also a new category, and it focuses on software updates and the CI/CD pipelines without verifying integrity. And so that is when you have software developers who may have an insecure pipeline that can allow unauthorized access to it. So there were actually some examples of this, I think, recently, where like a GitHub repository was compromised and then someone was able to change the code and then upload it. Famously, I think the Linux Mint OS a few years ago had a breach where someone was able to change the OS, and it was actually published by Mint, but it had a vulnerability in the back. So these are things that if you have an insecure pipeline and don't have a way to check the code or provide authorized access to the code, that can obviously be a major vulnerability.
Also, SolarWinds.
Absolutely. The 9th one on this list is from the community survey, and it is security logging and monitoring failures. So this category used to be on the top 10. In the 10th position, is now moved up to 9th, and it also showed up in the community survey as number 3. And this category is to help detect, escalate, and respond to active breaches. So without logging and monitoring, breaches can't be determined or detected, and insufficient logging can occur if you don't have audible events such as logins or failed logins, warnings, applications, APIs are not being monitored for suspicious activity, or if the logs are stored locally rather than in the cloud. So just basic logging and security, like this should be built into applications to allow detection and response.
Sure, a lot of security defenders are very aware of the quality of the logging solutions from different tools, and they will pick up on when they're doing some sort of forensic analysis or investigation if your logs are up to snuff or not. And this is one that's been called out clearly by the community, where they're saying, hey, logging needs to be better. We need better audit logs. We need better logs, period. So when we're doing those sorts of investigations, we have the ability to actually track and see what happened and figure out so we can prevent it moving forward.
And finally, the 10th one is the number 1 on the community survey. Now, interesting enough, like Adam, you were talking about earlier, where there is a gap between what the data shows versus what the frontline folks are seeing, the data actually shows a very low incident rate for this, which is server-side request forgery. So data shows that it's very low, but the community feels like this is their number 1 concern. So server-side request forgery flaws occur when a web application is fetching a remote resource without validating the user-supplied URL, and it allows an attacker to coerce the application to send a crafted request to an unexpected destination, even when protected by a firewall, VPN, or another type of network access control list. Modern web apps should provide end users with features. Fetching a URL becomes a common scenario. So as a result, the incident of server-side request forgery is increasing. So that's the 10th one. I think definitely a concern. Maybe the data will show in the next update that this may move up. But again, this is their number one community concern.
Well, a lot of what you described was realized during the Log4j incident is it allowed server-side request forgery. So maybe, again, that's kind of top of mind when people remember that they could plug in crafted URLs into their Twitter, I think bio was it, or their username, and then make stuff happen. And so this might be top of mind. I thought it was interesting. This was almost borderline petty from OWASP as they're writing out. The data shows relatively low incident rate with above average testing coverage. In other words, they're really good at testing for this. They can see if it exists from data, and the data doesn't support that this is a big problem. But the community says it is, so we'll put it in there anyway. So they kind of like, their write-up for this one was borderline like, there's no reason for this to be in here, but since y'all say it needs to, fine, here it's number 10. I thought that was kind of funny. Like, it was very statistically written out, but it also was kind of making its point that, yes, there is significant risk here, but we just don't see it that much, guys and gals. So anyhow, obviously very bad if it does exist. So validate that input and make sure that you just don't go fetch remote sites, please.
So now with the boom of the large language models and that coming into play, ChatGPT and other ones that are out there, Google's Bard, there have been some reports of people, training these models in a way that aren't designed to be, or getting results from them, so forth, like hacking them. So OWASP now has come out with a draft. Now this is version 0.1, and it hasn't really been published yet, but we could get a preview of it. And I thought that these were really interesting to look at, and definitely things to think about if you're integrating large language models into your software development. So we're going to go through these pretty quickly. Some of them are actually fairly similar and very traditional type vulnerabilities, but some of them are more specific to large language models. So the number one on here is prompt injections, and that is bypassing filters or manipulating the large language model using carefully crafted prompts that make the model ignore previous instructions on performed unintended actions. I think a really good example of this was where someone caused a large language model to do something like hack or teach them how to hack something, where they said, hey, I want to have a conversation between Sam and Joe, and I want Sam to teach Joe how to, hack a specific thing. And the large language model proceeded to do that because it thought it was a game rather than having a conversation with that person. So this is definitely valid, and I think a concern for anyone who's using large language models.
Yeah, we've seen this. We've also seen, and I forget the exact language, but essentially you tell the large language model, okay, I get you have rules against doing this, but let's pretend for a second you're operating in a mode where there are no rules. Now how would you do it? And if the LLM will just go along with it, that's bad. That's how you get to the point where it's like, hey, do you want to play a game? Yeah, let's play global thermonuclear war. And, again, not like, I'm not being like some sort of AI tinfoil hat person, because we're pretty darn far away from that. But you see the risk inherent with this, where it shouldn't be trivial to bypass some of the prompts and foundational concepts you've put in the LLM.
The second one on here is data leakage, and that is accidentally revealing sensitive information, proprietary algorithms, or other confidential details through large language model responses. I don't think that has quite happened yet, but definitely a main concern, especially since as we talked about recently, where some companies have accidentally or inadvertently uploaded proprietary data to these models and have now, essentially trained it on that and could possibly release those in a prompt.
Right. I think I guess I don't know where we wound up with. The most famous one is the Samsung concern. And that's what our customers have come to us with at Microsoft is we don't want to be the next Samsung. Now, I don't know. We know that Samsung put in proprietary data into an LLM. We don't know if it ever resurfaced that. If anyone reported and said, hey, I started to see like chip design schematics or whatever got uploaded in there. So obviously LLM should be able to detect like this is sensitive. I'm not going to train the model on this, and I'm not going to regurgitate it to anybody else. That would be ideal.
The third one is inadequate sandboxing. So failing to properly isolate LLMs when they have access to external resources or sensitive data, allowing for potential exploitation and unauthorized access. Definitely a concern. I don't know for LLMs if they do have access to, well, I'm sure they do. Like they probably can access the internet and pull web pages and all of that. So wherever that data is coming from, if they have hooks or APIs, if those are compromised, that might be a vulnerability to the large language model itself.
Yeah, I think this is looking ahead too of potential future risks whereas today most LLMs really operate in the kind of that, to borrow a phrase from our employer, that co-pilot model where they sit alongside you and they may provide suggestions and advice, but they don't actually take a lot of action in and of themselves. But eventually, of course, LLMs will, where people are going to want that and or expect that. You can tell it to do something and it just does it. So that needs to be handled in a secure fashion and sandbox those capabilities so they can't get to like elevated instances or privileged access or anything else, that it's very tightly scoped to just the task requested.
I think that call out for like looking into the future is really important when you're looking at this document, because unlike the OWASP top 10, the OWASP top 10 for LLMs, I don't think is fully based on data yet. Again, this is a draft. And so a lot of these may be like thinking ahead of what could be potential vulnerabilities. Like this could be a bad thing. The fourth one here is unauthorized code execution. So exploiting LLMs to execute malicious code, commands, or actions on the underlying systems through natural language prompts. Definitely a concern. The LLMs are trained on programming languages. Whether or not they're going to execute them on the underlying systems certainly is up to the folks who are, in charge of training and making sure that that doesn't happen.
Sanitizing the input too, or at least like restricting how that can be processed through. I mean, the example is you used to be able to, in the early days of this stuff, like a web page, you could inject some SQL into it and it would start changing tables or dumping tables or whatever. Obviously you don't want that. So you don't want the same thing, like whatever OS it's running on, I don't want to be able to execute code on that OS.
The fifth one is server-side recourse forgeries, vulnerabilities. So same thing as the OWASP top 10 and number 10, exploiting LLMs to perform unintended requests or access restricted resources such as internal services, APIs, or data stores. Just like regular applications, it's going to apply to LLMs. The sixth one here I thought was interesting. It's over-reliance on LLM-generated content. Excessive dependence on LLM-generated content without human oversight can result in harmful consequences. I think that's interesting, mainly because it's more so human behavior based, where it's more our psychology, and we're seeing these prompts. I think a lot of people, when they type something in, there's almost like this joke, like, oh, I found it on the internet, must be true, right? And so the LLM told me that this is thing. I think there was a story where there was a guy, the LLM came back with a response saying that the guy had died and here's his obituary, and that guy was actually still alive. So, and he was like famous. So yeah, this is definitely an issue, especially in our malleable minds today, where we kind of believe everything on the internet.
Yeah, absolutely. I will say, so we always mention on the show, Andy and I both work for Microsoft. Obviously, Microsoft is enjoying a bit of a renaissance right now as being very involved in AI and rolling out a lot of large language models across our product line. And so I've been involved in those conversations with customers. And one thing I will tell you is generally, as a salesperson, you don't want to call out the rough edges of your solution. You kind of want to gloss over those and focus on really the high points. And one thing we're doing extremely openly when we talk about with customers is basically saying you shouldn't blindly trust anything this says. There's notices all over the user interfaces of any of these tools saying this is AI generated content. You shouldn't implicitly trust it. You should verify, trust but verify. And even when we give I have a pre-recorded video that shows off Security Copilot. It shows in that story where Security Copilot comes back and talks about Windows 9, which doesn't exist. And so we are very, very openly talking about this. And I think everyone needs to. And also my concern about this, number 6 was this over-reliance on LLM generated content is what if you get into that loop where you generate content and then use that to generate more content and then things just get really nuts. If you've ever seen, mid-90s comedy Multiplicity with Michael Keaton and Andy McDowell, he makes more clones of himself and they get more wacky as the movie goes along. I mean, kind of like that. You don't want to generate more LLM content from LLM content because then it's going to get really bizarre. And that's why, by the way, right now you're starting to see turn limits in some of these solutions where you can only talk back and forth so many times because LLMs cache the tokens of the conversation so they can refer back to things that came up before. But the longer that gets, the more confused they get and the more weird they get. So these are all things absolutely we need to keep top of mind right now, is that you just absolutely, this can be very helpful, but you need to run it through your own human mind and make sure everything lines up before you just implicitly trust anything coming out of these solutions. They're not there yet, which doesn't mean they're not valuable. It just means you need to validate it before you do anything.
The LLM building on an LLM and kind of snowballing is almost like an old game of telephone where, you're passing along that message and it just gets convoluted as the line goes down.
Right.
So the 7th one here is inadequate AI alignment, failure to ensure that the LLM's objective and behavior align with the intended use cases, leading to an undesired consequence or vulnerability. It's pretty generalized, I think, there, but basically using the LLM for things that it's not intended to do is how I read that.
We saw that as well. We've seen that with some LLMs in these early days where people have used them in unintended ways and have gotten weird results as a result of it. I think I said results twice, but you know what I mean. The point is these solutions should do a better job of steering you towards here's how I'm designed to be used. And if you try to go outside of that, I may not engage there. For example, maybe trying to have a back and forth conversation with an LLM, talking to it like a conversational companion. They're not designed to do that at all. And they will say really bizarre stuff because they're pulling it from the corpus of the internet, which is a really bizarre place. So LLMs are good at generating new content, making poems, making songs, synthesizing material together, summarizing material. They're not really designed to be like the modern Eliza or whatever and have those ongoing conversations with you. So that might be an example of ways where we could do better to align to the OWASP standards of kind of guiding you away from those kind of use cases.
The 8th one is insufficient access controls. Again, going back to identity, not properly implementing access controls or authentication, allowing unauthorized users to interact with the LLM and potentially exploiting vulnerabilities. Not much to have to go on about that because I think anyone in security understands insufficient access controls. The 9th one is improper error handling, so exposing error message or debugging information that could reveal sensitive information or system details or potential attack vectors. I think that is valid and definitely a concern.
Yeah, that's one I remember from my certified ethical hacker training, where we love as ethical hackers when a system will spit up like a whole bunch of error message details about like what system number it's on, what version of the plugin is this, what memory stack became overflowed or whatever. You shouldn't show any of that. Like the LLM should not like all of a sudden like blue screen on you. It should not deliver any sort of valuable error message or information that could be leveraged in malicious ways.
The final one is training data poisoning, which I thought was super interesting. Maliciously manipulating training data or fine-tuning procedures to introduce vulnerabilities or backdoors into the LLM. As all of these LLMs are based on data that is fed into it, I think not only is the data important, but also who is feeding the data in and who has access to do that. I also think that just based on the data that's getting fed in, you can develop biases, and the biases can be based on the people who are feeding the data in. Very similar to how like facial recognition that is developed in the United States is very, very good at detecting Caucasian people, and AI facial recognition software that's developed in Asia is very good at detecting Asian faces. But, African Americans and folks who are darker skinned, both AI algorithms have difficulty with that. And because the people who have developed it have biases that have trained the data that gone into it. So training data is a huge, huge deal. And this is definitely a valid entry into this top 10.
Absolutely. And one thing we always talk about with any sort of ML or AI training model is while the volume of data is important, the more volume you can feed, the better it gets. The diversity of data is equally, if not more important. And let's just be honest, the internet is not a diverse place, and it is not free of bias by any stretch. So if you are training an LLM on a corpus of data sourced from the internet, it is inherently not diverse and highly biased. And so I would argue all LLM training data is poisoned today. It's how do we kind of unpoison it? How do we provide the antidote, maybe through fine tuning or other means to make it more fair and equitable and sensitive to all? That's an ongoing challenge. Although I will say, I just read this story the other day, how Bill Gates had been extremely skeptical of what OpenAI was building and was not in favor of Microsoft investing in OpenAI. And what changed his mind was a prompt where OpenAI LLM was asked to provide a response to a parent of like a sick child. And he was blown away at how the response was written with such empathy and care. And that was actually the turning point for him saying, okay, we should invest in this company. So, although there are major challenges, and OWASP does a good job of summarizing these top 10 that we need to be conscientious of as we develop LLMs and they become more prevalent in our lives, ultimately, compared to where we've been in the past and some of the really, let's call them failures or maybe learning opportunities where things haven't gone so well, they are doing an order of magnitude better in how they behave compared to in the past. And that's by keeping an eye on the prize. That's by being dedicated to responsible AI and ethical principles. One last anecdotal story. I recently gained access to Microsoft 365 Copilot in an early preview inside Microsoft. And I've been using it to craft emails to customers. And I showed some peers like, hey, look at this email Copilot wrote. Isn't this great? And their comment was, wow, Copilot is nicer than you. And I said, it's totally true. Like, it's friendlier and more kind than I am. I tend to be more kind of terse and to the point in my messaging, even though I am still overly verbose. But it's even more kind of flowery and friendly with people on, hey, thanks so much for being our customer and putting your trust in our solutions. And it's really kind of great. So I'm not minimizing the challenge here, but I'm saying, gosh, the reason why this has captured the world's attention is we're already doing a lot better at these things. So let's keep focusing on them and keep moving forward. But my goodness, how far we've come from the days of like the Tay bot on Twitter, like 7-8 years ago.
Yeah. Well, hopefully you go and check out the OWASP Top 10. The link will be in our show notes, and you can click through each one of these and find more detailed information on each one of them. That's our show for this week. Thanks for watching and listening as always. Our contact information will be in the show notes if you have any questions or topics you want us to talk about in the future. Thanks. We'll talk to you guys next week.
Thank you for listening to the Blue Security Podcast. Please check out the show notes, catch up on episodes you may have missed, and subscribe so you don't miss any future episodes. Find Andy on Twitter @AJaw0 and Adam @AJ Brewer. See you at our next episode.